So this semester we've been looking at how to distill arguments and how to then put them into standard form, how to symbolize arguments, how to construct truth tables in order to determine whether or not the arguments are valid. And I know that a lot of you at this point are probably having this sort of frustration as to what's the payoff to any of this? How does any of this help me in my job or anything else? Is this information we've been learning in any way practical at all? And I'm going to, in this lesson, give you just a brief glimpse of the ways in which many of the lessons we've covered, particularly the ones we've been covering at the tail end of this class, symbolizing propositions, symbolizing arguments, can in fact be quite beneficial or have some kind of practical payoff in the end. And what we're going to be doing is looking at just ordinary arguments and then symbolizing those and using truth tables to determine validity of the arguments. And before we get to that, I want to just look at some other ways in which some of the information that we've studied is practical. We are going to be looking at how to distill an argument and put it into symbolic form and test validity. This is going to be the lesson for today. But beyond that, I also want to show you how even using symbols and looking at the connectives that are being used when someone writes or speaks can be beneficial just for clarifying what it is we're talking about. And I only am going to give one example of this because I don't want to belabor the point too much. But something that's become important in recent days, actually something it's a question of interest from time to time, is about the status of immigrants in the United States. And the Constitution of the United States, the 14th Amendment, Section 1, says the following: all persons born or naturalized in the United States and subject to the jurisdiction thereof are citizens of the United States and of the state wherein they reside. And this is the section of the constitutional amendment which people typically think for or typically think of as giving people what is called birthright citizenship. In other words, basically if you're born in the United States, then you're an American citizen, right? And basically, regardless of how you got here, as long as you're here, you're born here, then you are a U.S. citizen. But a lot of people, I shouldn't say a lot, but some people have challenged this understanding, and they've challenged the idea of birthright citizenship. And it really hinges on how we read this constitutional amendment and how we group the connectives being used. Now, this is a pretty complicated phrase. I shouldn't say phrase, but proposition. As you can see here, we have a couple of things going on. First, we have this quantifier at the very beginning, all right, going on, born or naturalized and subject to the jurisdictions are citizens of the United States and of the states in which they reside. There's a lot going on here. We have several different connectives. But if we want to break this down, we're going to kind of simplify this a little bit because I want to focus on what is the key constitutional debate here. You have to think of exactly what this is saying and how these various propositions, because there are several atomic propositions, fit together. My understanding, well, this is the way I think a lot of people naturally view this, is they basically think, hey, if you're born in the United States or you're naturalized, then you are a U.S. citizen, right? That's kind of a nice, easy way of putting it. But what people who reject birthright citizenship say is they say, if you look at this and you say all persons born or naturalized are U.S. citizens, then you're leaving off this entire clause here, and subject to the jurisdiction thereof. And they say that right there, it is qualifying this first clause here, all persons born or naturalized. It's qualifying that. And it's putting limitations on who would get citizenship in the United States. And we can symbolize this in various ways, but here's a way to understand what's going on here. Let's suppose we were to take B, and B represents, I'm going to simplify this, basically all persons, so this is taking longer than I thought. All persons born are, that is terrible, born are That looks like a we are U.S. citizens. Sorry. I'm using my mouse in order to type this, so it's like really aggravating. It's not even using a stylus. So let's say B equals all persons born in the U.S. or U.S. citizens. We'll say N represents all persons naturalized or U.S. citizens, and then we're going to say that all persons, we'll use S, all persons subject to the jurisdiction of the United States are U.S. citizens. How do these three propositions connect, B, N, and S? And here is some dispute about how we should even read this amendment and what it is saying. And there are different ways we could symbolize it, but I think symbolizing this really makes it quite clear what is going on. And here's the way I think that is the most natural way to symbolize it. B or N and S. We could actually symbolize this in a different way. There's another way we could symbolize it that is equivalent. For instance, you might do something like this. B and S. So you're born and subject to the United States, or subject to the jurisdiction, I say, or N and S. All right? Or you're naturalized and subject. Now, this proposition right here and this one, these are actually equivalent. I know that doesn't look like it. That's supposed to show you the biconditional here. But these are actually equivalent. I wrote it this way just because that's more in line with the way this is being worded up here. But these propositions are actually equivalent. And the reason I'm sharing this with you is because this right here brings to light what the constitutional issue is in this particular amendment. Because what some people argue is they're going to say that just because you're born here, that doesn't make you a citizen if you're not also subject to the jurisdiction of the United States. Just because you're born here doesn't make you a citizen if you're not also subject to the jurisdiction of the United States. So let me back away from that for a second and let me share with you the truth table for this, because what this is going to show you are the conditions when you would be a U.S. citizen. So basically, you look right here and we have our truth table laid out, and we see that this compound proposition is only going to be true in three occasions. The first occasion where it would be true is if you're born here and you're naturalized and you're subject to the jurisdiction. Well, this one, honestly, it doesn't make a lot of sense because, if you're born and you're subject, or you're naturalized and you're subject, it's kind of redundant. So once you fill in the content of this one, of these atomic propositions, this first row right here really doesn't apply because it just doesn't make a lot of sense. But look down here. These other two do make a lot more sense, because what this one is telling us is if you're born and you are subject to the jurisdiction, then you're a citizen. Or if you are naturalized and subject to the jurisdiction, then you're a U.S. citizen. But what this rules out is any time where you might be born here, but you are not subject to the jurisdiction. See, this row 2 is saying you're born here, but you're not subject. And this one's saying you're born here, but you're not subject to the jurisdiction. So what this right here, this proposition, when we interpret it this way, what this rules out is that basically that it rules out the idea that you could just be born within the geographical boundaries of the United States and that automatically renders you a U.S. citizen. And there are actually very clear cases of people who are born within the geographical boundaries who aren't. Basically people who have any kind of diplomatic status, like people who have like diplomatic immunity. If they're born on, for instance, an embassy here in the United States, then they wouldn't be U.S. citizens. So we do have clear cases. But what some people have argued, and I want you guys to understand this, is that they'll say that basically immigrants who are in the country illegally, that they are not subject to the jurisdiction of the United States. That any illegal immigrant is not subject to the jurisdiction of the United States. So any illegal immigrant would not have birthright citizenship. And go right here. So someone who's an illegal immigrant, for instance, they would maybe be, let's see, wrote like this right here, where they'd be true, yeah, you're born, but false, you're not. Actually, it wouldn't even be that because they're not naturalized. So it actually would be this row right here. True that they've been born here, but it's false that they're subject to the jurisdiction because they're illegal immigrants. So therefore, they wouldn't be U.S. citizens. It would be false. Now, they would say by comparison, someone who is here legally, then they would be like, let's see, this row right here, row 3. It's true they were born here. It's true they're subject to the jurisdiction of the United States. So they would be U.S. citizens. So you see, this is really important, the stuff we've been talking about, because it impacts these constitutional debates that people engage in. Once we get this cleared, what this amendment is saying, which I do think it is something like this. There are other ways we might write it that are equivalent, but this is what it's saying. Then the conversation turns to, well, what does it mean to be subject to the jurisdiction of the United States? Then it comes to analyzing this proposition. But we can't get to that point until we clarify what the amendment is actually saying. And that's where our symbolic logic becomes so important, because it makes it very, very clear. We are saying something like this. Here's something we're not saying. We're not saying something like this. Sorry, I got a little carried away. We're not saying something like this, B, or, N, and S. It's clear this is not what we're saying. If this is what we were saying, then basically you would have this is very clear that you would have birthright citizenship just by being born in the United States. What this would do is, if we had the parentheses here, it would restrict the scope of being subject to the jurisdiction. It would restrict it only to those who have been naturalized. That doesn't seem to be what is being said, and I don't think any constitutional scholar has ever argued that's what is being said. It is clear that subject to the jurisdiction is arranging over both, or is being applied, I should say, to both being born here and being naturalized. But the constitutional question really becomes, how do we parse what do we mean by being subject to the jurisdiction, right? But as I was saying, we can't get to that important question of understanding subject to the jurisdiction until once we get clear on what the Constitution is actually saying, the logical form. And as I was indicating, this is where studying a little bit of symbolic logic can really be helpful. Because, honestly, I read the Constitution as it's written up here. It's a bit unclear to me what's being said. But, well, sorry, I got a little clicky. But once I write it like this right here, I'm like, oh, I see what's going on here. The only way for this proposition, this compound proposition, to be true, if my cursor will come up, the only way for this compound proposition to be true is if both conjuncts are true, right? And here are the conjuncts. B or N, that's one conjunct. The other conjunct is S. So the only way for this compound proposition to be true is you have to be subject to the jurisdiction of the United States. And that's where the symbolic or the symbols become really helpful, as they clarify that all-important meaning of the 14th Amendment. So this is just one example. Actually, in your homework, I have another example of where being able to symbolize something actually helps you understand, as you're going to see, the Second Amendment a little better. But here's one way, or one practical application of symbolic logic. I want to look at some other but other common arguments that you might come across, and we're going to look at how we symbolize these and how we can use truth tables in order to put some of the skills together and test validity. Now, a long time ago, and by a long time ago I mean a week or two, I had taught you guys how to take an ordinary English sentence like this one right here and put this into standard form. Now, what we're trying to do with this is we want to figure out, is this a valid argument, yes or no? And you might be able to determine it just by looking at it, whether or not it is a valid argument. But some of these arguments won't be so easy, and so it'll be useful to be able to symbolize them and then use the truth table test of validity in order to determine if they're valid. Now, as I was saying, I taught you guys how to symbolize this kind of argument here. I'll die unless you kiss me. So let's just say we had D unless P. Actually, I should save this. How would you put this into standard form? Because remember, this is not an if-then. What we do, if you recall, is we switch these and then we negate the P. So basically what this is saying, I'll die unless you kiss me, is saying if you don't kiss me, then I'll die. So to put this argument into standard form, first we have to put this first proposition into standard form, which would be if you do not kiss me, then I will die. All right? I don't know why I use P over here. I should have used K to stay consistent. But if you do not kiss me, then I will die. Then the second premise is you kiss me, therefore I won't die. Now, we want to put this into symbolic form. Right here, I've just left it in plain English just so we could see the argument. But how would we symbolize this argument? Well, the first thing we have to do is figure out what our atomic propositions are. One atomic proposition is you kiss me. Notice the not here is a connective. Another one is I will die. Here we have you kiss me, and then I won't die. So we could use different letters here, but let's say we use a kiss for kiss me. So it's going to be not kiss me, then I will die. You kiss me, therefore I won't die. Not kiss me. Or just like this, we put it in symbolic form. If you don't kiss me, then I will die. You kiss me, therefore I will not die. So this is how we would symbolize the argument up here. The way I did that, just so we're clear, is the first thing I did is I put it into premise conclusion form, but I use the plain English because it's a little easier than thinking with symbols initially, just to keep it like this. And then once I had this, and I had these propositions in standard form, because remember up here, this proposition is not written in standard form because it has the conditional written in the middle of it. Let me rephrase that. It doesn't have if, antecedent, and then the consequent. It's not written that way. It's got unless, and we have to get it into if, P then Q form, which is what I did right here. So this is how it's going to look when all is said and done. And then we can construct our truth table in order to test validity. And here's what our truth table is going to look like. We have our K, our D, the not K, then D. I'll just go back a slide. So not K, then D. K / not D. And then we can do our truth table here. And we look to see if we have any row in which we have true, true, false. And lo and behold, right here, we have a row. True, true, false. So this argument is invalid. I will die unless you kiss me. You kiss me, therefore I will not die. That's not a valid argument. It's actually an instance of denying the antecedent. Because look, our antecedent is not K, and then our next premise is K. Well, K is denying that not K is true. This right here is basically saying not K. So this is denying the antecedent of our first premise. So this argument was invalid, and like I said, you might have been able to see that, especially you might have been able to see it once you put it into standard form, and you especially might have been able to see it right here, but the truth tables prove that this is an invalid argument. So this was an example. Probably the hardest part to all this, the part that always confuses students the most, is getting this plain English argument all the way into symbolic form. That can be really, really tricky at times. Like once you get to that point, I think constructing a truth table to prove validity is the easy part. But taking this ordinary English and making sure you place the connectives in the right place, that can be really challenging. But speaking of which, let me give you an argument that's pretty tough. It can't be true that Beyonce is faithful and Jay-Z is not faithful. Well, we know that Jay-Z hasn't been faithful, so Beyonce isn't faithful either. Right? I mean, we know about Jay-Z's problems. Beyonce told everything she had to in her album Lemonade. But here's an argument, and we need to ask whether or not this is a valid argument or not. Well, it can't be true that Beyonce is faithful and Jay-Z isn't faithful. We know that Jay-Z hasn't been faithful, so Beyonce isn't faithful either. Well, let's put this argument, I'm saying standard form here, we're going to put it into that and then try to figure out whether or not this argument is valid. It can't be true that Beyonce is faithful and Jay-Z is not faithful. Jay-Z hasn't been faithful, so Beyonce isn't faithful. Is this a valid argument? Is it a good argument? Well, the first thing we have to do is we're going to use our truth tables in order to determine whether or not it is. We have to translate this argument and put it into symbolic form. And I think the hardest thing is going to be premise 1 here. This is going to be challenging. Putting premise 2 into symbols and premise 3, not too bad. But the question here is, how do we understand this? What are we saying here? It can't be true that Beyonce is faithful and Jay-Z is not faithful. It can't be true that Beyonce is faithful and Jay-Z is not faithful. And here is how we do that. And it looks like this. Not B and not J. Now, you might be thinking to yourself, wait, Mr. Newton, how in the world did you get that? Why is it not this? Why is it not B and not J? And the answer to that question is kind of complicated. I'm going to try to explain it in a couple of different ways. But the way that, one way you might look at it is you might just read it and say, it can't be true that, and then you see all of this right here. Beyonce is faithful. Oh, whoopsie. Sorry. What's going on? There we go. You might just read it and say, see what it's saying. It can't be true that Beyonce is faithful and Jay-Z is not faithful. And I should say, I'm using B to refer to Beyonce is faithful. I'm using J to mean Jay-Z is faithful, and I put the not in front of it in order to indicate that he's not faithful. So B is Beyonce is faithful. Jay-Z is faithful. Not J, means he's not faithful. So the question is, well, why this and not this? And the answer is, like I said, you might just be able to read it and say it can't be true that, and then you see that this part right here is being grouped together by this connective. But there's another way you can think of this, and this is actually how I do, is I focus on what the sentence is saying. And what it seems to be saying is basically that if Jay-Z is not faithful, then Beyonce won't be faithful either. It can't be true that Beyonce is faithful and Jay-Z isn't. In other words, if Jay-Z isn't being faithful, then Beyonce is running around too, right? So we could express this using the conjunction here, which is the way that they do it. But this could also be expressed in a different way, a hypothetical way, which is to say, well, if Jay-Z is, think of it this way, if Jay-Z is cheating, then you know Beyonce is cheating. Right? If Jay-Z is not faithful, then you know Beyonce is not faithful. And if we do that, if we think of it in hypothetical or conditional, then our truth table is going to look like this. So if Jay-Z is not faithful, then Beyonce is not faithful. All right? But notice this. This truth table, this right here, this conditional, is equivalent to this right here. Not Beyonce and not Jay-Z. All right? Or not faithful, right? These are equivalent. You can just construct the truth tables and you see that if Jay-Z isn't faithful, then Beyonce isn't faithful is equivalent to not Beyonce and not Jay-Z, all right? These are equivalent. This down here, though, not B and not J, this actually is saying something different. And what this is telling us is that the only time this proposition is true is if both Beyonce and Jay-Z are being unfaithful. But see, go back to this slide here, if it will. Go back. Go back to this. It can't be true that Beyonce is faithful and Jay-Z is not faithful. I mean, that sentence is true even if Jay-Z is being completely faithful. If he's not cheated on her at all, right, then it's still true that Beyonce would cheat on him if he cheated on her. All right, it's still true. But what this proposition here is telling us is that basically it can't be true. There's no it can't be the case that Jay-Z is being faithful and Beyonce is being faithful. This proposition here basically basically rules out them being faithful to each other, and that's not what's being said. What's being said is if Jay-Z is unfaithful, then Beyonce will be unfaithful to him. All right, so it's a different thing that's being said in this proposition right here and this one down here. So once you get this, which is easily the hardest part, and I don't know if I even explained that particularly well, but like I said, you can look at the truth tables here, and the way I think about it is, go back, the way I think about getting to this point, symbolizing it like this and not this, is I just think about what's being said, which is if Jay-Z is not faithful, then Beyonce is not faithful. And you could even, if you wanted, hey, here's the thing. If you didn't want to write this, you could have written not Jay-Z, then not Beyonce. You could have written that as your first premise instead of this because they are equivalent. So you could write either one that you want, and they're equivalent. That would be okay. In fact, here you go. Here's where it gets interesting. You could have also written this right here. Beyonce's being faithful entails that Jay-Z, because remember, this right here is the contrapositive of this statement right here. And so this statement is actually logically equivalent to this one down here. So this is kind of interesting because when we talk about equivalency, notice we could write this first premise in a lot of different ways. We could write it just as I've done right here. We could write it like this, or we could write it like this. They all have the exact same truth conditions. So, all right. So we got the first premise hopefully nailed down. Now, Jay-Z hasn't been faithful. Okay, we know he hasn't, right? That's true. We symbolize that, not Jay, and then Beyonce like this. Now, is this argument, is this a valid argument? Well, let's use our truth table test of validity, and here we go. And we can look at this, and what we're looking for is there a row in which we have true premises and a false conclusion? And the answer is no. There's no row in which we have true premises and a false conclusion. And in fact, if we go back a slide, I just told you all that you could rewrite this premise right here in a different way. And one way you could do it is just as this. And notice, what do you have right there? If you wrote this first premise like this would be a case of modus tollens because you're denying the consequent. You could have also written a first premise like this. And notice if you had written it this way, you'd actually have a case of modus ponens because you'd be affirming the antecedent in that case. So this is a logically valid argument form. We can use our truth table in order to determine that. And I think it's also really fascinating that we can, like I said, rewrite this first premise either as, if B then J, or we could write not J, if not J then not B. They have the exact same truth value as this one right here. And this is a logically valid argument. It's, again, you probably could have figured that out from your intuitive sense of things, but the truth table proves it beyond any doubt that this is a logically valid argument. All right, I have one more example for you, and then I'll let you go about your business and do your homework. Smith is guilty of burglary if and only if he took the goods from Jones's residence and she did not consent to their removal. Smith did take the goods, but Jones consented. So Smith is not guilty of burglary. So here we're going to write the argument out, and Smith is guilty of burglary if and only if he took the goods from Jones' residence and she did not consent to their removal. Now, I'm not going to break the if and only if up at this point because now we have a symbol for that, which is the 3 bars. So we're not going to worry about breaking that up. Smith did take the goods, but Jones consented. So Smith is not guilty of burglary. Now, we want to symbolize this, and in order to do that, we have to figure out all the different connectives we have going on, as well as figure out the different atomic propositions we have. So the first one we have, let's see, Smith is guilty of burglary. We have if and only if he took the goods from Jones' residence and she did not consent. Wow, so we have three connectives going on there. So we might, let's say for this first atomic proposition right here, Smith is guilty of burglary, we use a B. If and only if he took the goods from Jones's residence. So for he took the goods from Jones's residence, I can't remember what letter I used, but let's say T for took, and she did not consent. And we'll use a C, which C stands for she consented. That's not working. She consented to their removal. So we have here B, if and only if. We have and notice here that what's going to go on is we're going to have a parenthesis, because burglary, if and only if, and then we have a parenthesis right here to represent that he took the goods as being grouped with she did not consent, T and not C. So we'll rewrite 1 to look like, hopefully I used those letters when I did this. Oh. Well, I want that to be a B. So we're going to use a B for that instead of S, because Jones is guilty of burglary. So that'll be our B. Smith did take the goods, but Jones consented. All right, so here's the key here. What is but? Well, but functions as and. So Smith did take the goods, so it's going to be T and C. Get rid of that S because I want it to be a B. And then so Jones is not guilty of burglary. So this is going to be not B down here. Oh, look, I knew I had a slide in which I'd use B. So here's how our argument looks. Jones is guilty of burglary if and only if, and these are grouped together. He took the goods and Jones did not consent. He took the goods and Jones consented, therefore he's not guilty. And so is this a valid argument? Well, let's put it on our truth table. We got a lot going on here, and here is our truth table. And what we're looking for is, again, a row in which we find that the main connectives, or the propositions, the premises are true and the conclusion is false. So look at this. We only have, this only is true in 2 occasions. Right here, this is false, so we don't care. True, true, true. So this argument is actually valid. Again, it might be something that upon reading it you can just immediately see, but for a lot of us it's not always exactly clear. And I hope that you got a sense from this video lecture, and I don't know if I did the best job of it, but you get a sense of how we can take these ordinary English arguments, which maybe aren't always completely transparent, and we can convert them into symbols, and then we can test validity or prove validity for those arguments. Like I said, I mean, I think, especially to me, the constitutional issue that I was raising at the beginning is probably the clearest case of practical application that we can see from some of the things we've talked about. But I do think that even beyond that, the ability to see how connectives fit together, even if you don't always symbolize them. You know, I didn't have to symbolize that, the amendment, in order to see how the connectives are going. Or being grouped together. It would have taken a little bit more explaining to do. And in fact, normally when I read constitutional debate about it, what you'll see is people on one side of the aisle, they'll say, well, what the Constitution is saying here is they're saying that being born requires that you're also subject. So they just spell it out using a lot of English words, which is fine. It's probably more natural to do that in most contexts in life. But the symbols cut through all of that. You don't need additional explanation. You can just see, okay, well look, this is being grouped with this and it's being excluded from that other thing. That's what the symbols enables you to do, is just to see in an instant how the propositions are being grouped together. We can go beyond just, the first exercise I gave you with the constitutional issue was just to show you how using the symbols can bring clarity to an issue. But beyond that, just bringing clarity, we can also determine whether or not an argument is a valid one. And we can, just like with what we've been doing, use the truth tables in order to determine that. So hopefully you can see how this can be applied and how it can focus you or teach you to think in more precise terms than you may have otherwise, where you're looking for clauses and you're saying, well, here's a clause that appears at the end of the sentence, but is this clause, being applied to one clause that came before it, or is it also being grouped with all the clauses that came before it? Is it being grouped with the clause that came at the end? Or is it being grouped with another clause? I mean, these things are really important and vital for understanding truth conditions for individual propositions. They also impact whether or not an argument is going to be valid or invalid. If I were to go back here, let's go back to my favorite one, which was Jay-Z example. This argument would actually turn out to be invalid if we had read this differently. If this argument had been the way that we were saying, you might understand it, which is not B and not J. If we had understood the first premise to be that, this argument wouldn't be valid. It would be invalid. It would be invalid. So understanding the first premise this way is vital in order to determine whether or not the argument is valid. If we had misunderstood how these connectives were being grouped up here, that would have completely changed the tone of the argument. It would completely change whether or not it was a good argument. If we understood it this way, clearly bad argument. Understanding it this way, the argument is valid. So this is really important for learning just how we group connectives like not, and, or, if, then. For understanding what people are saying. If people say, I'll do that unless such and such happens. What does that unless mean? Well, that unless means if not Q, then P. That's what it means. And I think that's a really vital skill to have. So I want you guys to have a little bit of practice doing some of these translations. The problem is, oh snap, I have one more for you guys. I forgot I have one more. The problem is the book doesn't really have a lot of good examples for you to do. So I've devised a worksheet for you all. But before I get to that, I do want to share with you one more example. So we'll do this because, I don't know, I think this one's fun, and the World Cup just happened not too long ago. So here's one final example, then I'll share with you your homework. So you're a true Englishman only if you pull for Manchester United and know all the words to God Save the Queen. Henry pulls for Manchester United and knows all the words, therefore he's a true Englishman. Well, the first thing we need to do is put this into standard form. So you notice here that the way it's initially written, we have only if, right? Which only if is not in standard form. So we have to get it in that if-then form. And anytime you have P only if Q, remember, only if Q, what you're basically saying in that case is if P, I'm not going to write this out because, oh, I guess I am, then Q. That's what you're saying. P only if Q is if P then Q. So if you're a true Englishman, then you pull for Manchester United. That's a football team for you guys, or soccer team, and know all the words to God Save the Queen. It's a song. It's also, I think it's the anthem, or the national anthem for United Kingdoms. Also a good song by the Sex Pistols for anyone who cares. If you're a true Englishman, then you pull for Manchester and know all the words. Well, Henry does pull for Man U, and he knows all the words to God Save the Queen. Therefore, he's a true Englishman. All right, well, let's put this argument into symbolic form. And we're going to use E for true Englishman, and we're going to use an M for you pull for Manchester U, and then we'll use a G for, or no, I think we'll use a W for you know the words to God Save the Queen. So the way we symbolize the first premise is going to be as follows. You're an Englishman. If you're a true Englishman, then you pull for Manchester United and know all the words. So this one is a little tricky because Henry pulls for Man and knows all the words. So this is technically going to be a different proposition than what we're saying up here, which is you're a true Englishman. But we're just going to use it like or do it like this. This is just keep it simple, and this works out fine. But you know all the words. I mean, you pull for Man and know all the words, and then we'll just say, therefore, Henry is a true Englishman. So here's our argument in symbolic form. And once we get this, then we need to determine whether or not this is a valid argument. Now, you might just be able to see right now it's not. In fact, this is guilty of the fallacy of affirming the consequent. In this particular case, notice what the consequent is. This is the consequent. It's saying if E, then M and W. This entire conjunction is the consequent. And then it's saying that is true, therefore the antecedent is true. And that's just a fallacy. But we're going to use our truth tables in order to prove it's a fallacy, and here we have it. And so I've already constructed this for you. You don't have to do it all. And we notice we come right down here, row 1, 2, 3, 4, 5. Row 5, true, true, false. And we see that this argument is invalid, and row 5 proves that. So I don't know, you might have read this argument and thought, yeah, that seems to make sense. And I'll go ahead and tell you, a lot of people reason this way. A lot of people reason this way. But, and it seems to just be a natural thing to say, especially once you start adding these various clauses into something you're saying. You have like multiple things you're adding with connectives like or and. You keep piling on these. You throw in the only if here. And then people are like, oh yeah, that makes sense. But actually the argument doesn't when you break it down and you test its validity. So it's, again, just practical application of some of the things we've been studying this semester. And hopefully you can see too how everything we've been doing has been building on one another in one way or another. Again, we talked at the beginning of the semester about validity, and we used the test there, the method of counterexample, in order to test validity. Now we've gone well beyond that. That was just the kind of intuitive thing we were doing. Well, we can actually sit down, write up a truth table, and just prove that something is invalid. It's like, well, look, here we go. We got all. What this table does is it shows us every single combination of truth value for the atomic propositions, and we can prove, hey, look, row 5, your argument is invalid. Now, I don't know if you'd want to do that at a bar where people are talking about, Manchester United and God Save the Queen. You probably just say, yeah, he's a true Englishman. Otherwise, you might get in a fight. But you'll be the better person for it. You'll know that they're an idiot for using fallacious reasoning. So, all right. So, as I was saying earlier, I gotten a little ahead of myself. There aren't good examples in the book. I was looking at the homework that the book gives, and they're just some of those had like 5, 6 different atomic propositions in them, and you'd have to construct the truth table. One of them was going to have like 60-some rows in it, and I thought, there's no way I'm assigning that, because A, I don't want to do it, and B, I don't want you guys to have to spend your entire time writing up a truth table. So I'm going to post on Blackboard just a worksheet. It'll be attached to the homework, and there are only going to be 5 questions on it. One of them is a constitutional issue. I'm curious to see what you guys come up with for that one. But I want you to do this, and what you're going to be doing for your homework assignment is you're going to translate the arguments into symbolic form and then test them or prove validity or invalidity with the truth tables. Like always, if you have any questions, please feel free to email me.